Hello, my name is Heather Patno, and I work for the Bureau of Reclamation in the Upper Colorado Basin region within the Power Office, dealing with hydropower and reservoir operations. Thank you for the opportunity to provide information about the Colorado River Basin Ensemble-Based operational forecasting methodologies to determine risk and uncertainty during drought. First, an overview of the Colorado River Basin hydrology. The Colorado River is geographically located in the Rocky Mountains and southwestern United States, covering portions of Wyoming, Colorado, Utah, New Mexico, Arizona, Nevada, and California. 16.5 million acre-feet is allocated annually, with 7.5 million acre-feet allocated each to the upper and lower basins, with 1.5 million acre-feet allocated to Mexico. Historically, there have been 16 million acre-feet of average annual natural flow, with 14.8 million acre-feet in the upper basin and 1.3 million acre-feet in the lower basin. The Colorado River is a western river system, and inflows are highly variable from year to year in accordance with snowpack, soil moisture conditions, and temperature and climatic responses within the river system. In order to mitigate for the highly variable hydrology, the upper and lower Colorado has 60 million acre-feet of storage, or about 4 times the annual average inflow. These reservoir operations and water deliveries are governed by the law of the river, which includes the 1922 Colorado River Compact, along with various compacts, legislation, court decisions, and records of decisions. The upper Colorado and lower Colorado River have been in a drought for the last 2 decades. The driest 23-year period on record has occurred beginning in 2000 and including the 2022 forecast through the end of this water year. Water year 2021 was the second driest inflow into Lake Powell since 1964. Lake Mead reached its historical low level since it began filling on June 8, 2021. With a new low elevation reached on December 3rd, 2021 of 1065 feet. Lake Powell reached its new historical low elevation since first fill on July 24th, 2021, and has continued to decline to its current elevation of 3527 feet, or 25% of capacity. This graph is showing the Lake Powell end-of-month elevations from the beginning of filling through January 2022. You can see that in the 1980s and 1990s through to September 1999, Lake Powell was essentially full. Starting in early 2000 and continuing through April 2005, Powell's storage decreased 2/3% of capacity. Various operational mechanisms and operational records of decisions were put in place in order to respond to the drought. With these operational mechanisms in place and variations in hydrology, Lake Powell has remained around 50% of capacity up through water year 2020. Water year 2020 had 54% of average inflow. 2021 had 36% of average, and current projections forecast 66% of average inflows this 2022 water year. During this time, we also had some of the driest soil moisture deficits and warmest temperatures on record, further decreasing runoff from the near normal snowpack within the upper basin. Our current capacity is now 26% and is forecasted to continue to decline. Reclamation has provided an update of potential and forecasted operations into the future for decades. We have done this under the 24-month study process, which is updated monthly and looks 24 months into the future. The water supply assumptions are based on synthetic hydrology that combines the current year National Weather Service, Colorado Basin River Forecast Center forecast, and statistical inflows in the out year with deterministic reservoir operation assumptions. The maximum probable uses the 10th percentile or blue line. The most probable is the median or 50th percentile in green, and the minimum probable is the 90th percentile represented here in red. This covers around 80% of the potential uncertainty in the current year and provides insight into a range of potential future operations. Over the last decade of drought and experience with updating this monthly synthetic hydrology, Reclamation has been limited in the ability to forecast the extreme hydrology that we are seeing. In order to address that, Reclamation updated its modeling procedures and methodologies to incorporate the National Weather Service Colorado Basin River Forecast Center 30 ensemble traces or potential forecasts based on historical temperature and precipitation, current conditions, soil moisture deficits, and water use assumptions, and logic-based operational parameters from the Bureau of Reclamation. Reclamation has updated its modeling methodologies so that we can now show the extremes, the maximum probable and minimum trace. The gray cloud here covers the full range of operational uncertainty during these times of drought, and operational projections now cover the 10% of potential traces above the maximum probable and below the minimum probable, showing us the full range of potential hydrology and reservoir conditions into the future. Uncertainty remains as we update the forecasts monthly based on observed hydrology and reservoir conditions in the system. This modeling upgrade allows us to respond to potential extreme drought scenarios and operational extremes while continuing important conversations with our stakeholders as we're responding to them through the process. I hope that you have enjoyed listening and learning about Reclamation's updated methodologies using ensemble-based forecasting in our operational modeling system. If there are any questions, please feel free to contact me in the future, and I would be happy to provide more detailed information. Thank you very much for the opportunity to be here today.